Hello! I think it's about time that we all talked about debugging and how to debug, because I've been doing some programming and not really talking about how we eventually find problems in every bit of code and basically how to flush them out, how to debug, how to find the problem and remove it. So that's what we're going to talk about today, basically how to debug. So who is this for? This is probably for aspiring software engineers, beginner, intermediate, or even experts. Or you could just be curious viewers looking to see how the normal software engineering workflow takes place. So debugging itself comes from physical mechanical machines used to be used for computing, and the first actual computer bug was a literal insect in the mechanical machine, and that's where the term debugging comes from. Before we go any further, there are a few different things we need to talk about in terms of debugging. So it's not just blindly trying to find bugs. There are a few different types of debugging methods that can be used. Let's talk about four main ones I've noted down here, basically from least efficient to most efficient. So there's brute forcing, that maybe is known by other names, but I'm just going to call it brute forcing, and that's basically where you don't really have a debugger and you basically put in printfs everywhere to see what happens before and after a statement, variable, or function, and yeah, just using printfs everywhere and changing inputs to see what happens at the output. So that's generally brute forcing, and if you don't know where you're looking, this can take a really long time, and it's sometimes not as well, it's not the most efficient way to debug. So this is why the other methodologies come in handy. So cause and elimination, so this can be thought of as a fault tree, or I've seen a colleague using it recently with a fishbone diagram, and that's basically gone through the different function calls and gone down and ruling them out. So I will likely put up a fishbone diagram or a fault tree in the B-roll so you can see what that looks like. Then the next most efficient after that, I would say, is binary search debugging, and this is basically, binary search is an algorithm, but it's also a debugging methodology, and yeah, it's basically split the program into two parts. Is the problem in the first half, or is it in the second half? And if it's in the second half, you go, okay, take the second half and split it into two parts and do that until you get to where the bug is. And then lastly, we have backtracking. So this is basically if you know where the bug is occurring and if it's replicable and repeatable, go to where the bug's occurring and you basically step back through the code. There's also the rubber duck method. You will have possibly seen this rubber duck. I get this at a Christmas party, but it turns out it's a handy rubber duck to be using. So the rubber duck method is basically, instead of you calling up a colleague or turning and asking a colleague, you basically talk to the rubber duck and go, okay, this is happening because X, Y, and Z. Why is this happening? Because X, Y, and Z. And the rubber duck method can be thought of in the same vein as if you're feeling anxious and you write down a problem, whenever you see the problem written out or the things you have in your head written out, they don't seem as insurmountable. And it's kind of the same method. So once you hear yourself say something that is maybe tripping you up in terms of debugging, it can highlight the error. All this is easier said than done. It does get easier with experience, and it's like a muscle, you know, the more you use it, the better you get and the stronger you get with it. But the paradox, or the catch-22 of the situation, is it's not something you want to be practicing all the time. It's not something you want to be practicing all the time, because if there's loads of bugs in your code, it means your code's shit and you're not really being that productive. But it's also one of the things that you want to be doing so that whenever a bug does come about, that you're better and quicker able to find it. You're able to find it and be better. I don't know what I'm saying. Helps you find it quicker. There you go. With all that being said, how about we look at a few examples? Now again, in these examples, it's going to seem far easier than it actually is, partly because I know exactly where the bugs are, and partly because they're not that big of a problem, these bugs. These are quite nice, easy bugs, but we're going to look at them anyway. So let's just look at the code first and see what it has to do. So we've got main. This is C code, by the way, just in case anyone isn't familiar. We have main, and main will print some strings. and it'll add the value and print the added value. So if we go into this print strings function, this is the first function call. So this function is used to print 300 strings that counts from 0 to 300. Okay, pretty simple. And we have a few variables, our for loop, which goes around and prints, and it stores the variables. So then we have the adder, which is taking 5 and 6 and adding them together to get 11. So it takes one number in, takes a second number, add them together, puts them in a result, and returns the result. And then it'll come down here and print the numbers. Okay, let's just debug it and see what happens. So I'm gonna, we'll let it run first and see what happens. Debug anyway. Okay, it's giving me errors. It's got 2 errors. Okay, build finished. So generally speaking, the compiler can be your friend and it can show you what the errors are. And we have an error for added value on line 15. Anyone want to hazard a guess, leave it in the comments below. This would be more helpful if I had the actual compiler options set up better, but I don't, and that's where we are, so that's fine. I know what this problem is, and it's basically that the problem is we don't have this variable declared. If we declare that variable and give it a type rather than just writing lines, that should remove that error. So getting that adder variable was the first instance. So if we run this again, okay, everything looked like it ran there, but if we actually check the functionality, this function is used to print 300 strings that counts from 0 to 300. This is a bit more of a pernicious bug because it's a bit more hidden. It's not a bug that breaks your code, but it is a bug, and these are generally the ones that come back to bite you. Basically what we have here is this function is meant to print from 0 to 300, and it's printing from 0. It looks like twice for some reason. I don't even know why it's printing twice. That's an R bug. We'll worry about it in a minute. Oh, I do know why it's printing twice. It's because this is already set to 0 and it's going in here and printing the first time. So if we move that down, it'll print 0 once. Okay, that's that. So that's an RB bug there. But yeah, it's printing from 0 to 255 and then rolling over to 0. That's not right. And it's nothing to do with any arithmetic in here because this is going, well, we can double check that if we put a breakpoint there and play like stink. Okay, so we've reached 255 just before it rolls over, but we can see here I is 256. So in theory, string count should go to 256 before it prints, and it doesn't. It goes to 0. If you have a bit of experience, you'll know why this is happening, and if you don't, it can be a bit of a head scratcher. But basically the reason this is happening is because of string count itself, and as you can see here, it's declared as an 8-bit integer, 8-bit unsigned integer, whereas I is a 16-bit unsigned integer. And the reason that's happening is because, if I can get my calculator, it's kind of hard to see, I appreciate, but if we put all these on, this is basically our unsigned 8-bit integer string count. And what should happen is to go to 256, this bit should get set. If we set all these to 0, so it should go to 256, but that doesn't happen because what seems to happen is it goes back to 0. So all these bits that were on get flicked off and it goes back to 0 because it's only operating within these 8 bits because it's set to an 8-bit integer. So it just rolls over and goes, okay, I'm going to restart because I don't have the memory capacity for a 16-bit integer. So I'm just going to start at 0, then go 1, 2, and it just restarts and counts over again. So that's why that's happening. That's why you're seeing 2550, 1, 2, 3, 4, and so on. So in theory, if we change this, that should fix it, and we should see 0 to 300 being printed. Well, 0 to 299. I've made a balls because it should be less than or equal to, so that was another bug. There we go, 0 to 300, and that's basically that. So that's somewhat how you debug the few methodologies and a quick wee example or two. It's never that easy, so if you get a bug and you can't figure it out, don't worry, it's not you, it's a difficult game. So yeah, if you liked that, thought it was useful, give it a like, possibly subscribe. If you didn't think it was useful, give it a dislike, and yeah, that's me. Alright, bye.